All right, quick recap. What do you need to know from, what do you need to know about rules for differentiation? Guys, there's the constant rule, constant function rule. If y equals a constant, then the derivative is zero. Constants don't have a rate of change. There is the constant multiplier rule. And the constant multiplier rule says that if a function is equal to a constant times another function, the derivative of that function is the constant times the derivative of the other function. You can just pull constants right out front. There is the power rule for integer powers. And it says that if the function is x raised to the power of some integer, that the derivative will be that integer times x raised to the 1 less power, n minus 1. The product rule says that if a function is a product of two functions, that the derivative will be the first function times the derivative of the second plus the second times the derivative of the first. And the quotient rule says that if a function is a quotient of two functions, that the derivative will be the first times the derivative, the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. And the way I think about these is I say uv prime plus vu prime as a shortcut for memory. And on the second one, I say vu prime minus uv prime over v squared. Whatever you do to memorize it, you need to memorize those rules. The trick on both of these, a really good trick on both of these, is to write out u, v, derivative of u, derivative of v, so that you don't lose track. And let's see, there was another trick I was going to remind you of, which is right here. For negative powers for n less than 0, write as, that's not what I wanted to say. For reciprocal powers, so for 1 over x to the n, write that as x to the negative n before you start taking the derivative. You'll just find it much easier to use the power rule than to use the quotient rule. You could do the exact same thing on the left-hand side by using the quotient rule, but it doesn't make sense. Numeric differentiation, and this is useful when you're just collecting data as opposed to having a function. You would be given a function at some time. You'd be given a derivative of that function at some time. You'd be given another function at that same time, a derivative at that same time. And then you can just find y prime of a if y is equal to either a product or a quotient. You just plug in the numbers. Seems obvious, but sometimes people overlook that and say, I don't know what I'm supposed to do now. All I've got is data. And finally, higher order derivatives. You just need to understand that y prime is the derivative with respect to x. Y double prime is the second derivative with respect to x, not with respect to x squared, with respect to x. Y triple prime, third derivative with respect to x. And then y, the nth derivative with respect to x. The nth derivative with respect to x. Actually, I don't think we normally put that n in parentheses on the second part. So anyway, there you go. That is section 3.3. Everything you need to know. Thanks.